We are a senior design team from the CEGE department, and we will be talking about the biobeneficiation as pretreatment to flotation of pegmatite ore.
I'm going to share with you the base elements of our project and how it applies to the industry in the future. Our team was presented with a project scope that outlined our task and included basic information to put the project in perspective. Our job was to design a system that would biologically pretreat a designated volume of ore in order to enhance extraction further along the line. The specific elements of our process are an ore called pegmatite, a bacteria called polymyxa, and the target, the efficient extraction of lithium. Understanding the geology is crucial to understanding the process. The reason we need a pretreatment of the ore is that the base minerals of the pegmatite share many of the same traits. This means they can't be easily separated, and thus lithium cannot be easily extracted. Our design is based on the industrial practice that targets iron from iron ore. Our team uses much of the same research to build our system, though there are minor variances. The biological element that makes this all possible is P. polymyxa. This bacteria secretes polysaccharides that chemically alter the minerals. This alteration is just enough that the minerals can be easily differentiated and the flotation process is enhanced.
Next, we will explain our design process. Shown here is our final process overview that includes the tank volumes, flow rates, retention times, and bacteria concentrations for all major components of the design. All of these values were either pulled from research papers on beneficiation processes or calculated based on principles of wastewater and water resources. The bacteria, P. polymyxa, will be grown in 3 aerated and insulated growth tanks. These growth tanks are filled and emptied at staggered times to ensure a steady flow of bacteria to the mixing tank. In the mixing tank, the bacteria will interact with the incoming pegmatite ore slurry from the mine, thus altering the surface chemistry of the ore. The treated ore then undergoes dewatering before entering the flotation process.
Now we're going to talk about sensitivity analysis. A sensitivity analysis was used to alter some of the system variables to see if there are more effective values that could be used. The variables we changed all pertain to the bacteria growth tank. The variables included the temperature, limiting substrate, and the growth tank flow rate into the mixing tank. After altering the temperature of the growth tank, we found a slight temperature increase would increase the bacterial growth rate and lead to a smaller necessary inoculation concentration. After altering the limiting substrate, which is the food for the bacteria, it was found that there was no significant effect with a 10% increase or decrease. This is because we already selected the most effective concentration based on research. Alterations to the growth tank flow rate are directly proportional to the tank volume, yet inversely proportional to the bacterial concentration needed in the tank. Decreasing the flow rate seemed like a good option as it would decrease the already large tank size. However, decreasing the flow rate comes with a few issues. The design flow rate is already very small, which makes it difficult to fit to standard pump and pipe sizes. Therefore, a flow rate decrease could end up being more costly than the alternative.
Finally, I will be talking about recommendations we have for upgrading the system. Our first recommendation is to run pilot scale testing. We have never had the opportunity to test the growth procedure to see if the bacteria will grow in the abundance we need them to, so testing to verify they are growing like they should would be beneficial. Pilot testing also allows us to look at other improvements to the system, like incorporating algae into the growth tanks and possibly using the recycle flow to test if the bacteria can survive the dewatering process. We also think it's a good idea to run a life cycle assessment on the entire process. A life cycle assessment looks at the raw building materials, transportation, assembly, and use and disposal of everything that goes into a project and assesses the environmental impact of each facet of the design. Thank you for watching.